The first one that we are going to do is neutralization of an acid with a base on a laminated sheet of paper. I have taken here a piece of laminated paper. If you do not have a laminated sheet of paper, you can just keep a plain paper and cover it with a plastic sheet. That will serve the purpose. So for this neutralization reaction, the materials that I have taken are the commonly available ones at home: sodium bicarbonate, that is baking soda, citric acid that we use in the kitchen as a preservative, and of course pH solution, which we'll have to buy from scientific supplies. If we do this, we'll be able to do this experiment. So first we shall take these chemicals and put a little of it, that is not even a pinch. Microscale means very small quantities. Now I am taking a little of citric acid and putting it on this laminated sheet of paper. Then take sodium bicarbonate, that is baking soda, and take a little of it, put it on paper, close it, and leave the spatula there. Let us not change the spatula. Then we will have to take water in this dropper. If you do not have dropper, you can even use spoon. So put water in the middle. Now we shall take pH solution, pH indicator. You can take any indicator, even phenolphthalein or natural indicator that you are preparing, anything you can take, but I am taking pH indicator. Now you can see the color green because water is neutral. Take the spatulas and slowly push these chemicals into this water. To my left side there is citric acid. I am pushing that into water. And to my right side there is sodium bicarbonate. I am pushing that into water. These two chemicals will dissolve in water and then start moving towards each other. At the point that they meet, the reaction will take place. Now you can see the color of indicator at citric acid is turning red, and indicator at sodium bicarbonate is slowly turning blue. At the center still it is green, the watercolor. Gradually when this red color and the blue color meet, that is the site of the reaction. Citric acid will react with sodium bicarbonate and you will get sodium citrate with the release of carbon dioxide. So you will be able to see the bubbles of carbon dioxide at the site. Now itself you can see at the center the bubbles are getting formed. Right? The color also is gradually changing. One side it is completely blue, another side it is red. After some time you will find different colors, shades of red. Red, orange, yellow, and this side blue, and finally green. Yellow means very light or very weak acid, and red means strong acid. Now we can see the bubbles at the center, right? So if you are carrying out this reaction in a test tube, you will not be able to show them the change in color, nor will you be able to show them the movement of ions, the site of the reaction. The moment you add the chemicals, the bubbles will be formed, the effervescence will be formed, and the gas will be released. This is a better way to carry out the reaction, and it is easy and cleaning purpose also. There is no need to spend time. Just wipe it off. Now the sheet is ready for the next experiment. Thank you. Teachers, the next microscale experiment that we are going to see is displacement reaction. That is a double displacement or double decomposition, what we call. And this experiment can also be used to explain diffusion. I have here taken potassium iodide and lead nitrate. You can take even barium chloride and sodium sulfate, silver nitrate and sodium sulfate, and all that also you can take. Anything that we can use for double displacement reaction. So as we have done in the previous one, in the neutralization reaction, here also we are taking the chemicals, a little of it, and putting it on the paper. So here I have just put a little of potassium iodide on one side. Leave the spatula there. And I am taking lead nitrate and just putting a little of it on the paper and leaving the spatula there. Then with the help of a dropper, I'll take water and put a little of water at the center. So much is enough. Now we shall start pushing the chemicals into this little by little and see what happens. At the same time, I'll just push both. Even so much is enough, we don't need to take a lot of it. Now, lead nitrate decomposes into lead and nitrate ions. Potassium iodide decomposes into potassium and iodide ions. And all the four ions move. We can now see a yellow color line towards lead nitrate, but not at the center. It is at that point nitrate, lead, they decompose, lead is meeting iodide ion. So the yellow color precipitate is lead iodide. Now the question arises, why is not the precipitate at the center? The reason is lead is heavier than potassium. So lead moves very slowly. By then iodide comes and meets it. So the precipitate is formed towards lead nitrate. So this experiment can not only be used to explain double displacement, you can also tell them about diffusion and which is heavier, which is lighter, and heavier ions move slowly. So if you do the same experiment in test tube, you will get a whole lot of yellow color precipitation, but not this way a line formed. Microscale experiment, electrolysis of sodium chloride. The materials that we require here are common salt, that is sodium chloride, and I have taken the indicator phenolphthalein. You can take any other indicator that you like. 9-volt cell, crocodile clips, and 2 carbon rods. You can even use pencil leads. I have taken these graphite rods from used dry cells plus water, right? To begin with, we shall add a little of common salt, that is sodium chloride, on this laminated sheet of paper. Then add some water so that it dissolves. Yes, so much is enough. Then add a drop of indicator that you have taken. So if you are telling the students to do it, you can tell them to take turmeric as an indicator. The powder itself they can add. Even there also the yellow color will turn red. Now we shall prepare this cell, and you get this in the shop. Even this crocodile clip is available in electronic or electrical shop. To this you fix this carbon rods or pencil. Even pencil can be sharpened both the sides and that can be used, or pencil lead can be used. Now keep this electrode 1 inch apart in the cell, in the solution that we have prepared on the laminated sheet of paper.
Yes.
Now keep these electrodes just a little apart in the solution. You can just see the pink color appearing on negative electrode because sodium chloride decomposes into sodium and chloride, and sodium ions are moving towards negatively charged electrode, right? And if you just leave it for some more time, you will even see hydrogen being released at negative electrode, that is cathode, and chlorine released at the other electrode, positive electrode, right?